Hello, I'm Barry Palmer. This video will show you how easy it is to build a Sevtec Sev using modern composite hull construction. The vehicle we're going to build is the Scout. This is a little one-place vehicle, and it uses engines of the lawn and garden tractor variety of anywhere from 5 to 12.5 horsepower. It will carry 2 people with a 12.5 horsepower engine. The plans for this machine, which are all on this computer, will show you what a tiny vehicle it is. The hull is only 10 feet long. It's 5.5 feet wide. The machine has a 48-inch in diameter thruster, and there's a 20-inch in diameter lift fan directly under the engine. Now, one of the problems people have with building a machine like this is, where do they find a shop? Well, you may have a shop and you may not realize it, so let's go looking for a shop. Well, this looks like a good place for a shop. Actually, a shop can be as simple as a piece of black polyethylene tarp nailed to a eave and propped up with a couple of poles. But here, this is real civilized. We've actually got a roof over our head. We don't need any walls. But first we have to clean the place up. Well, I guess now that we have our shop, we can go out and start finding the ingredients to our shop. First ingredient is a pair of sawhorses. A good flat piece of plywood is another ingredient. Black polyethylene tarp for cold conditions is also needed. And a heater is another ingredient that's needed for wintertime operations. And oh yes, one of the most important ingredients. Yes, one of the most important ingredients of your shop is the hot end of a 110 volt AC power supply. See, it's no real trick to come up with a shop. I was to use good parts. It's crazy to try to save money on one particular type of part, and that's rotors. Sevtec and other people sell plastic rotors that are quite inert to the elements, and they do not get cut up by sand and water when the craft is underway. This is a ultra prop. It consists of a composite plastic blade and a hub assembly, 2 halves. The blade fits in blocks that determine the pitch that the blade is set at. And these individual setups are bolted into the hub in this fashion. And you can get any pitch that you want just by changing the pitch blocks. This is the fan. It's a multi-wing fan. Consists of a hub with 2 halves. The blades are inserted in sockets in this sort of fashion. Small pins are dropped in place. and the blades are set at controlled pitches. And then the other half of the hub is bolted in place to make up a fan. I can make up a fan anywhere from 3 to 9 blades with this assembly. It so happens that the vehicle we're going to build is going to use 6 blades, so that we leave every third blade slot open so we get a right power match with the engine. Now another item is the drive kits for Sevtec vehicles. They consist of all your belts, bearings, shaft, idlers, bushings, pulleys, and limited machining that's done to make the drive so that you don't have to drill holes in it and you don't have to do any machining. And another item that Sevtec sells is skirt material. This is a vinyl material. It weighs 18 ounces per square yard, and it has proved exceptionally durable in service. And the big beauty of this type of material is that we use a cement. It's a contact cement, and all you have to do is wait 2 minutes and slap the joint together and go on to your next joint, which makes skirt assembly a real breeze. There's absolutely no sewing required. Now another item that Sevtec does sometimes handle is the foam core material used in the construction of the hull. Now although I show the possibility of building plywood hulls, there is nothing that you can beat the quality of a foam core hull. And this foam is a structural urethane foam. It's available in several parts of the country. Sevtec sells it. And don't be deceived by other people who try to sell styrofoam or insulation foam or even furniture cushion foam for this type of foam. It's a special foam, and it will give you the best hull and the lightest hull that you can build. We've had craft in service for over 10 years with this hull material. The nature of the layup is this foam core with a layer of glass on each side, and it makes an extremely stiff, lightweight type of product that just really can't be surpassed for air cushioned vehicle hulls. Another item we can infrequently stock are engines. This is the 12 horsepower engine that's going to be used on Scout when we build it up. And this engine probably is capable of about 9.9 horsepower. For those of you that want to use it on small waters, the 12 horsepower is more of an advertising number. But it's just a single cylinder engine, recoil starter, a fuel tank's built into it, and a air filter is built into it, and it's got its own built-in muffler. So all you have to do is hook up the throttle, hook up a kill switch, and you're in business. This engine also happens to be an overhead valve engine, and we're hoping that these engines have the efficiencies that the new Vanguard engines have. The Vanguard is the, well, what else can you say, the Vanguard of this new type of Sev, and we hope this engine will also come up to the standards of the Vanguard engine used on Vanguard. We will find out, because we'll learn how to operate this craft, and we'll do some testing for the video camera and our video audience. Our shop set up, it's time to get down to the nitty-gritty of actually building Scout. The first thing we do is we start by trimming the foam panels to shape for the hull construction. The tools needed in this are a drywall square, an ordinary carpenter's square helps, something to draw with, anything that'll score the foam or will mark the foam will do, and of course the plans, and a knife to cut the panels. Just about any kind of knife will do. The first thing we do is select a part. We will look on drawing 2, right in the middle. There's a panel there called 8H8B. Let's lay that out. We first check the foam. Some of this foam is accurately enough cut so that it's square, and the outside edges of the foam can be used for references. In a lot of cases, however, the foam is not this accurate. So the first thing I do is look at the dimension, 38.5 inches, and I mark it with the drywall square. And with a calculator, I can locate a center line. 38.5 divided by 2 is 19.25 inches. And that's where my center line is. Since this foam is fairly square, and I don't mind seeing marks showing up in the foam when I have the finished assembly, I will just go ahead and draw the center line. At the same time, I know the part is 18.5 inches high, so I'll move the square along and mark 18.5. And 18.5, and I'll turn the square and mark the top of the part. Now you'll note that the narrow part of the part is 16 inches long. That means I have to go 8 inches on either side of the center line. Mark it at 8 inches and mark it at 8 inches. I can then draw the angular lines. Have panel H, A to B all laid out. There's no trick at all to laying out these panels if you work in an orderly manner. The next step is to cut the panel out. Just take your straight edge, lay it down, and start cutting. A series of passes is always better than a single pass. Panel. And away we go. As we progress to panel H9, we get a new dimension, and that the panel H9 has a wooden edge on it. This is called parting bead. It's 1/2 inch thick and 3/4 of an inch wide, and it goes on the edge. And to lay out the part properly, we just put this piece of wood up alongside of the foam. have your panel H9. Now, since you're going to make a left and right hand version of this panel, you can merely get another piece of foam and trace this outline directly onto the other piece of foam. New tool to add to our construction process. This is a glue gun. This one happens to be about 20 watts and it seems to be sufficient for the job. Now we're going to glue the wooden edges onto these forward side panels, and there is no intent here to gain strength with the glue joints. The only reason this is done is to hold the wood in place for the glassing of the panel. All you have to do is just press the junk together and line things up and hold it until the glue dries. In this case, until the glue loses its thermal energy. And you have it attached. It's best not to have any glue protrude to the surfaces, as you'll have to pick that off before glassing. But there it is with the wood edge installed. I've cut the scraps up and I've fitted them to extend the original 24 by 48 inch sheet of foam up to the full size of Scout's bottom panel. Make sure you get them fitted up and then glue them on. Here I'll use some weights to hold this one in place, as you would on a larger machine. There's really little advantage in having full-size sheets. The main reason they're 24 by 48 inches is so they can be shipped easily. Put together the two main side panels of the hull. It helps sometimes when you're using the scrap to just take a few passes of sandpaper to square up the edge so it fits tightly against the adjacent panel. Again, all you have to do is hold it until the glue dries, or actually cools down. getting out to lengths like this, the glue gun may run out, so it's best to skip the part. The glue gun's generally good for about 4 feet. Here we can use a little extra assistance from weights again. And there's one of our whole side panels. And here we have the basic elements to a hull. Everything from the aft cockpit bulkhead forward, all cut out in about an hour and a half. The next step is to install hard points so that we can put bolts through various parts of the hull structure without crushing the hull structure. First, we lay out the location of the hard points. And the type of hard points in this floor panel are nothing more than pieces of oak dowling. To cut the holes for the hard points, we take a ordinary hole saw and just by hand place it over the layout point and bore into the foam until a pilot drill hits the other side. These particular hard points will hold the upper edge of the partition skirt. These hard points will hold the lower inboard edges of the side skirts. So we've bored the hard point cutouts in one side of the bottom panel. We can flip it over, and where the pilot drill came through, we just place the pilot drill in the same hole and bore out the other side. This is so you can get the little foam slug out of the hole saw relatively easily. And that's all there is to cutting the holes. When doing the hard points on these quarter panels, remember that there are left and right panels, and the diagonal that you draw through the panel has to be the right way. Notice I'm just sticking it into my marked layout point. Drill in the other end. And out comes the plug. And there are all the round hard points. It didn't take but 15 minutes to put all those holes in these panels. There's another type of hard point. This is made using just the ordinary 1 1/2 or 1/2 by 3/4 inch material, and you place it where you want to put the hard point and then draw it. Take a small knife and cut out the cutout. You'll probably notice lots of background noises. The police have a rifle range right off opposite me on the river, which they use infrequently, but they usually use it when I need quiet. And you'll hear trains going by, and you'll hear backup beepers, and the sort of other goings-on, which are quite typical noises, but they sure show you what a studio is for. And there's your cutout for this hard point. The next step is to glue the hard points in. Here's our glue gun again. You don't have to glue them in well, they just have to be glued in so they'll stay in place. The polyester resin will set these pieces firmly in place because it'll soak into the glue. And there's that hard point. These hard points, just give them a little dab somewhere. Slip them in. The whole idea is just to hold them in place. You don't have to worry about any kind of strength, because the resin will soak in around them. Well, it hasn't been too tricky so far. Let's get on to the next step. And now we start the glassing procedure. Polyester resin is a gooey substance that pours even more viscously than motor oil. To this resin is added a catalyst, which we will not do now. We will wait until we're ready to actually put the resin in place. You'll note that the polyester resin is in a can very similar to the acetone can, only marked as polyester resin. It's because you can buy polyester resin cheaply frequently from people who get it in bulk, whereas if you go in and buy a gallon at the hardware store, it can cost a fortune. The other ingredients, of course, is that acetone for cleanup, paper towels, this is messy, micro balloons, which is a white powder which fills the resin and makes a low density material for filling spaces, and Cabasil, which looks like that white powder, only is used to make it sticky so you can stick things down. The tools of applying the polyester resin are squeegees, or a brush, or some people use a roller. And the materials, the glass cloth itself, consists of a fabric like this, which is just a regular muslin weave, nothing exotic, or a mat such as this, which has random strands of fiberglass about 1.5 to 2 inches long, just strewn randomly and bonded together by some type of binder that dissolves in the resin. Now the first step is to cut out the glass that you're going to apply to the particular panels. The first panel we'll start with is the plow plane. You know the plow plane needs one layer of glass cloth and one layer of mat on each side. You can either use the part as a template and just draw around it to get the shape, I would let the glass be about 1/4 of an inch to 1/2 an inch beyond the part. Now when you work the glass, you should avoid tugging at it because it'll get distorted. You don't have to cut perfectly because later on you will trim this glass off. Just cut outside the line that you drew first. And just lightly fold it up. Set it aside. The mat is cut similarly. Unfortunately, it's more stable and tugging on it will not cause it to distort. You don't have to be precise with the cutting. The idea of cutting off the edge is when the mat and glass wet out, they tend to sag over the edge of the part, and this should be minimized to make cleanup of the edge of the panel simpler. And oh yes, remember that heater that I placed below this table? It's been turned on and it's heated up the region underneath the table to around 75 degrees. It's about 60 degrees out here now, so it's not real bad for temperature, but it's nice to have a controlled temperature. This is for the other side of the plow plan. To catalyze the resin, I look at the size of the resin container. I know I want between 1 and 2% catalyst for the correct setup of the resin. The more catalyst, the faster it sets up. The less catalyst, the slower it sets up. I look at the diameter of the liquid on the top, and I'm going to use the cap as a measuring device. And I look at the diameter of the cap, and it looks like the diameter of the resin in the can is about 5 times what the cap is. And the surface area is the square of that, or it's 25 times the surface area. Or turning the numbers over, this cap has about 4% of the area of that surface. If I filled this cap to the same depth as the resin in the can, I would have 4% for catalyst. So I can see the cap is only about 1/4 as high as the amount. So one capful will give me about 1%, and we'll try 1% catalysis for the start. So I fill up the cap with the catalyst and dump it in. The resin is rather non-critical as far as stirring goes. I have the plow plane again. I notice there's a little bit of a wormhole in it, which the foam tends to have little defects. I take some of the resin, pour it out, take the micro balloons, which will form a putty, and put some in and mix it until I have a paste that gives me a satisfactory condition for. And I dab a little in the hole. and strike it off. This is the plow plane. We start with mat. Now I'm going to find out how much resin I'm going to use, and I'm going to weigh the resin in the vessel that I'm starting with so I can weigh it after I finish and see how much resin is used. The resin and container weigh 10 ounces. Some people use brushes, some people use squeegees. First objective is to get it moved around and distributed on the part. Some people do something called slurrying the foam, where they actually rub the resin and some microballoons right into the foam when they start this procedure. But you can see it's that initial 10 ounces minus 2 ounces, or 8 ounces, was about half as much as we need. So we're going to have to hit it again. I'll put another 6 ounces in. Container weighs 8 ounces, so now we have 6 ounces invested. We have to catalyze again. Remember how much we put in before. We only have 6 ounces. We put in a smaller lid full. It's not real critical. It's not a good idea to lay the brush on the work, incidentally. And we pour it out. Now bubbles will form, and generally you can get the bubbles out by stippling them with a brush. You work all the bubbles out. Get the surface so that there is no pileup of resin on it, and there you can just sort of barely see the weave in the fabric. This is not aircraft construction, where they use a procedure called vacuum bagging, and they pull the mat. They don't use mat, but they pull the cloth down tight against the foam with a vacuum. That's a little exotic for a Sev. And the first panel is glassed. Now we want to cure our panel out. This isn't required in warm weather, but in colder weather, this panel's small enough you can lift it up without disturbing things too much and put it underneath into the heater. When the resin gets rubbery after a period of cure, you can sometimes knife the edges off quite neatly with a razor blade. It helps to wet the razor blade in acetone. And sometimes it can go as neat as can be. Like that. I have invested a total of 7 hours in this project so far in 2 days of working. The panels are now half glassed, and I have about a gallon of polyester resin into the panels. Time to glass the second side of the panels. It becomes more important here that the work surface is flat. And here I have a chunk of the aluminum skid material, and I can sight across it and see if there are any dips and wows in the panel. This particular deck happens to be part of an old roof that was ripped off because it had rotted out. I have this plywood setting on another layer of this old roof material, and it's blocked up to make the surface flat. Twist in the panel is not real important, but it's best to get rid of as much as possible. Put the glass on is the bottom panel. Now you have to check these panels for projections because the resin frequently works through the panel and it will stick out and cause a problem when you glass the second side. Some spots will have to be sanded. You'll notice I forgot some hard points. I drilled the holes in with one of the sides already glassed, and I will place them in micro balloons and pop them in place when I lay this side out. Slurry that we use to fill the pits can now be more resin and less powder so that it will run into the layup and it will not be able to run through onto the table. Put our missing hard points in. That's all there is to it. And then we work our micro balloons into these joints. Fastidious glassers, more of the experts, would prefer that the resin be put down first, distributed, and then the mat laid into the resin. This might not be a bad idea for everybody beginning in this glassing procedure. It is a lot better control in distributing the resin. Remember, it has to be laid down thickly because the mat will soak it up. Takes a little more time, but this is probably a more standard method than just laying it all down at once. Pivoted, it's time to lay in the mat. You should have plenty of margin for the mat to hang over the edges when you do this type of process, because it never goes on straight. There's the mat. Next thing is to touch up the dry spots. Now that the mat is down and the resin is distributed, it's time to lay the cloth into the layout. Always that easy. The extra resin that's in the mat will now be soaked up by the cloth, giving the lightest layup practical without vacuum bagging. And the resin will distribute itself with a little rubbing. Pots can then be gone over with a little more resin. Get the bubbles out by stippling with a brush. You should always try to keep the edges of the glass down, or they will sag over the edge of the panel and cause difficulties in cleaning up later on. It should be noted that when these large panels are glassed, they're still quite rubbery, and when you place them off the table, you should use a strong back, as this aluminum skid material is being used here, and the panels must be placed on a flat surface or they will not remain flat. Third day of construction, and now we have all our main panels glassed, and we have approximately 10 hours invested in the whole project. After the basic panels are completed, the next step is to bring the edges into bevel. You see the little bevel marks on the drawings? Look at drawing sheet 2. Upper left-hand corner, and you'll notice a 1-2 with the bevel mark by it. This means 12 degrees. The 12-degree bevel takes about a 1/10 of an inch plus offset of these two skid material guides to get the correct bevel. The important thing is that the bevel has to be accurate. If you have low spots when you're sanding it out, do not chase them, leave them, but maintain the accuracy of the bevel. Later on, when we join the panels, we can fill the low spots with micro balloons. This is all referenced from the center line that it was marked at the start of the foam construction. And there you have your bevel. You should also make sure that the panel stays square and in dimension. Using the center line as the primary reference, check the panel for square. And this panel is still square. Some of the edges are merely square, and all you have to do is sand them down to the original marks that you laid the part out with. Now, the reason I'm going to all this trouble to get accuracy is not so much for the Sev itself, but to make the assembly of the panels easy. You'll save time in the long run by spending time on beveling the edges correctly. It's time to get on with assembling the panels. You'll notice I've set these blocks with spring clamps to hold the front of the plow plane up, and I've also got these skid material edges to make sure that the floor panel is at a proper angle. I first place the plow plane in place and bond it lightly with hot melt glue so it does not skid around. Line up the center lines. Make sure that I've got the proper 4 inches of lift on the plow plane, as shown in the center right of drawing 2. The next step is to apply the fiberglass. Normally you put a bead of micro balloons in this joint But this joint is so tight that I'm going to let it drip a little bit. Get your mat in place. This mat's a little under 2 inches wide. And lay your cloth into the wet mat. Then check and make sure it's still in position. And that's all there is to joining the panels. This setup is similar. All you have to do is tack it together with hot melt glue and make sure things are square. On these right angle joints, I've mixed a micro balloon paste so I can get these joints in radiused a little bit, and the glass will work around the corner better. I just do it with my finger. Some people might do it with a tool. Quite easy if you try to work a little bit on the neat side so things don't get out of hand. At the end of the 4th day of this project, we now have 13 hours invested and we have used almost 2 gallons of resin. One thing nice about the hot melt glue on this false work is you can just break it out and the part is free. The hull side panels are next. You'll notice that we use the same technique that we used up to lift the edge of the plow plane. The side panels are lifted 8.2 inches above the plane of the bottom of the Sev by means of these aluminum angles, which will be the skids, and a small block and a spring clamp. You'll notice there are lots of weights all over the panels. These are to force the panels into alignment for the final setup of the resin. You'll notice that I'm also using a hot light on a short section on the other side. This is due to the fact that I couldn't line this panel up entirely without forcing other sections of the panel out of alignment, and I'm doing this joint in 3 pieces. The light will accelerate the cure time, but you have to be careful when you use a light or the resin can cause a burn in the layout. And now it's time to put the forward quarter hull panels on. Again, it's the hot melt glue routine. Put it on fairly heavy. Put it in place and let her cool down. It helps to check to make sure that the 15.5 inches dimension of the height of the bow is maintained. By referencing to those skids. And we're a little high, but I think we can live with it. And the bow plane can be put in place. Yeah, hot melt glue guns sure make this project easy. What do you know? It all fits. Here's another view of the bow structure. Now all the panels have been assembled. The plow plane is the sole support, and here are your straight aluminum angle skid material used as a reference. We're at the 5th day on the job. We've expended a total of 17.4 hours, and things are moving right along and looking real good. Some of these panels are best made by fitting the foam to existing panels, and these curved side panels at the sides of the aft body of the SAB hull are an example. If you get your scrap of foam, in this case you can use the scraps up, and here we go with a hot glue gun again. On a panel as complicated as this, you just might as well hold it for the full duration of the cure-up. Controls the width of the SAB. Well, here we are. We have 20.3 hours invested in the project, and you could go fishing in it right now if the fiberglass were dry. It's time to bring the hull into true and get the deck structure on. And we can plane these angular pieces down with an ordinary jack plane, making sure that the angle is kept reasonable to the top of the hull. Now's the time to start with the deck structure. The joinery is rather crude, so we'll help it with screws and epoxy glue, which has good properties in filling joint gaps. Epoxy should be used here instead of polyester resin, as a polyester resin is a terrible glue. that's the basic joinery. Here we are, 22.6 hours into the project. It's our 7th day, and we have about 35 pounds of Sev completed. It's very light. And hopefully it'll stay light and portable when we get it finished up. And now it's time to put the helm in place. The wood is nothing more than 1/4 by 3/4 inch screen molding. Kind you hold screens onto wooden windows. I'm using an epoxy glue. Again, polyester glues are no good. Polyester resin is not a good glue. Just bend them in place. Since this is near the maximum capability of this material, I just hope I don't break them. And I'll keep adding to the laminations. Again, hoping I don't break it. Now that the helm is in place, we can attend to the bow. We're going to put a 1/2 by 3/4 inch wood leading edge on the foam. So we very carefully mark it out. This bow point is the important part for referencing in the future, and we should work with this with great precision. Just cut off the extra foam with a razor, then sand it down into shape, and hot melt glue the wood in place and glass. That's all there is to it. Pop in a couple of hard points, and your bow structure is ready for glassing. Remember, epoxy glue must be mixed very carefully. Some people might prefer to make this part in the more traditional way by laying it up on a form, but this is certainly the quick way. Now we attend to the bow. These stringers will then be planed off so they fare into the bow, and this bow will be fiberglass top and bottom with a single layer of 6-ounce cloth. The structure for the back of the Seva, we put this wooden railing around, and we filled in the open panel with this piece of foam unglassed on each side and just free bent into place. Now it's time to glass the interior surfaces. We want to glass the non-cosmetic interior side first so that the foam will be stabilized, and then we can clean the outside up to a maximum without having the foam move around on us. Use up all those big scraps of glass cloth you've generated on this project and turn them into little scraps. If things don't lie down for you, just put a piece of aluminum foil over them and seal the aluminum foil down to the layup. And that part of the layup will stay laid down against the wood and the foam. Little bit of luck, and if you pull a aluminum foil off parallel to the surface, the aluminum foil comes off and the glass stays stuck. And now on with positive flotation compartments on the back of Scout. While the foam paneling itself gives quite a bit of flotation, this gives a little bit of added flotation in the rear where it's important, because when the Sev is empty, all of your weight is on the back end in the engine and air drive. The interior of the flotation compartment is glassed with 6-ounce cloth first. And remember that there are 4 hard points here for the skirt attachment. And remember that you have to have a hull drain hole, and you have to have drain holes for these positive flotation compartments that drain into the hull proper. Now the first step in coming up with a panel to close up the hull is usually to make a cardboard cutout the shape of the closure, and then from the cardboard cutout you can make your foam panel that will be the closer. Glass it only on one side so it'll remain flexible, and then bond it to the hull with micro balloons and glass fiber tape in a position that you can warp it into shape. Now I've redesigned this hull because as it's turning out, these curved panels are taking up a lot of time. And when you build this hull, I would put this panel in first before you put in the panel for the side bodies. I've removed the design where we have the curved side body and put in flat panels, so this process should be a lot easier when you go to build your Scout. So far, we have not had to resort to Cabosil in this layup. This particular resin that I have here has been particularly forgiving in that the cloth and mat do not tend to lift off and form bubbles. But if you have a resin that does tend to lift off, you will want to use Cabosil in with the resin to get a stickiness with the resin that will stick the mat and the cloth down to the layup. Notice the binders in the mat will eventually let go with the resin on it, and the mat will conform to the surface. Some people prefer to use a 2-inch cloth tape for this application, but it's expensive, and it also means it's another thing you have to buy. Basic construction procedures for forming a hard edge on a composite panel is to put in a solid microballoon bead in the corner of the panel. The underside of this aft deck is already glassed with 6-ounce cloth, and I'm going to cut a groove with this tool in the foam above the glass and put this channel in to put the microballoons in. That's all there is to it. To fill that with micro balloons and you've got a nice hard edge. The glass cloth on the deck will be rolled over the edge into the wet micro balloons, and that will complete that edge. Here you want the edge of the glass soaking so it will hang over the side. Notice these are cosmetic surfaces, so I'd be real careful with them. Care here, and in sanding the foam before putting the glass down will eliminate a lot of work. Didn't that go slick? These edges is the easiest way to get the extra material off. Just wet your knife in acetone and whiz right around and off it comes. Twist out of the hull and put these diagonal braces in to make the hull torsionally stiff. We anchor the center part of the diagonal first, and we have set up these strings that are in an X on the upper deck, and we have the strings tensioned with a weight, and by watching where the strings pass each other, where they intersect, we can tell whether the hull's twisted or not. It so happens this hull is very straight, and these weights just hold out a minimal amount of twist. We measure the height of the strings above the bottom, and that's our main reference plane, and they're all the same. So it looks like the hull is epoxy glue. This time we've mixed it with micro balloons to make it stay around a little better. Up really fast for the whole wooden parts, and you have one of these things, go right ahead. It makes quick work of a long task. The main structural components of the hull are done now, and one thing I would like to emphasize is that weight is very important in air cushion vehicle construction, as it is in a lot of products that you don't even think about. We want to keep the weight as low as possible and maintain good structural properties of the hull. Vanguard is built similarly to this hull and has been running for 2 years and has had no structural problems whatsoever. And I have had hulls built in the same manner that have run 10 years and have had no problems at all. So do not beef it up. Now if you're going to carry this hull, it's time now to look at where you're going to mount the handles, and I would mount the handles on the insides of these deck longerons, and you can locate it just by picking the hull up. And you can tell where the handles are going to go. I'm now going to weigh the hull just by stepping on a bathroom scale with myself and the hull. And I weigh 208 pounds with this hull. And then just step off. And I'm at 155 pounds. That means the Sev weighs, as it is now, 53 pounds. Well, here we are 12 days out in early October, and it looks like we got all of the big parts of the hull done. What remains is the aircraft fabric deck and general cosmetic cleanup of the hull. We're in the 12th day of the build-up, and approximately 37 man-hours have been used. So now it's time to go for a ride. Not the one-wheel variety this time. Let's try no-wheel drive. Now it's time to get on with the air drive. It would be nice if we had a shop that had a drill press and a bench vise and a drill press vise, but really you can get along without that if you're a little bit careful. So the first thing we're going to do is we're going to make a drill guide. We're going to take this 1-inch square with a .083 wall thickness tubing and mark it so that we can put a drill hole in each side of it, and when we use the hand drill, our holes will all be square to the member that we're drilling out. The first trick is to take a couple of blocks of wood. First, mark your piece with a scribe or a nail, as I use. Mark it on one side and mark it on the other side, and then mark it on the end. Now if you've got a square cutoff, you can just turn it over and mark it the same way on the other side. And now you will notice that we have two lines defining the center line of the part and one line defining the end. Then we can use a punch and we can punch out a starter for the drill. Like that, and like that, and then it's just a matter of we're going to keep the holes small for as long as practical. This is the drill guide. You merely clamp the drill guide over the spot you wish to drill a hole. Make sure the drill will penetrate both sides, and then just drill. Now locate the air drive carefully on the hull. And we do this by first drawing a line where the bolts that hold the forward part of the air drive are going to pass through the hull, locating them relative to the fan bore. Now people that are building this Sev as a one-piece craft will have the fan shroud already being formed instead of just this hole. And these people should be especially careful in locating these air drive holes, and also the fan bore should not be glassed at this time, so that final adjustments can be made by sanding the foam rather than having to sand glass. Now the first thing we have to do is transfer the engine mount hole locations to one of the 1-inch square longerons in the air drive. The bolt hole spacing can be located just by placing a piece of paper over the mounting holes and depressing the centers of the holes, and you get a very definite mark as to how far apart these holes are. Now the holes on the right side of the engine are not spaced the same as the holes on the left side of the engine, and many of these engines have different bolt patterns that are shown in the plans, so this should always be done. Drive longerons are then bolted to the engine after drilling, And we can set the engine up. Notice that the propeller drive pulley has been installed. We can set these up on 4x4 blocks. Lastly, this is another form of assembly for these tubes. This is brazed construction. However, in the case of this small vehicle, these 4 holes could be used to hold the entire assembly together without brazing. However, some people may wish to braze. I do not recommend welding with this tube because I've had mixed results in strength with this sort of an unknown material. Now the next step is to start assembling the air drive. Sort of a mock assembly to get the belt length set up correctly. Frequently the shaft will put up a fight in going through these bearings, and it's a good idea to take it off and look for burrs or some obstruction rather than forcing the issue, because if you force the issue, it may become irreversibly stuck to the bearings. Our pulley is then installed so that we can come up with a basic fit up for the belt. Where to move things. Then the idlers have slots in the square tubing, and they're bolted to the square tubing for alignment adjustment. They're bolted in place next. Lastly, step is to assemble the air drive and get your belt fit. Sometimes the belt will roll over backwards on you, and you have to make sure that the V part of the groove of the pulley is fitting against the V part of the belt. Is to align the idlers, and that's merely done by having a C-clamp available. Move the idler into position so the belt runs onto it in a true manner. Take a straight edge, place it along the flanges of the pulley to see where it will intersect the main propeller pulley, and it looks like we've got pretty good alignment right there. You also have to check that the alignment on the thrust pulley is also correct, and the thrust pulley can be moved up and down the shaft a little bit so long as there is pulley leaving shaft available for the lift fan to pilot on, and that's the way you line the belts up. It's not really that difficult. It might be mentioned that diagonal bracing is also installed at this time. This brace takes the thrust loads. That's all that's needed. You could have 2 smaller braces on each side of the engine, but this engine's muffler would be in the way, so I put the brace entirely on this side, and it's only about 12 inches up and 12 inches into the rotor stand, and it's more than strong enough to take any thrust that's going to be applied to the propeller. And we can place the air drive on the bench, and we can drill out our remaining holes in the air drive and locate the idler alignment permanently. But we still have to maintain the slots so that the idlers can be tensioned, although generally the belt will only need to be tensioned once after initial run. Now we turn all those big scraps into little scraps by making the fan shroud. The first step is to cut sectors with this template and an ordinary kitchen knife. It's just a plywood template, and we come up with these individual 60-degree arcs out of the foam, and then we stack the foam up like so many bricks. Remember to use very little glue and keep the glue away from the edge so that when you sand it, the glue won't interfere with the sanding. Just work in a workmanlike manner and keep everything square, and this will minimize the sanding. If you overlap them like bricks, it'll also help the accuracy of the buildup. And so much for the fan shroud, which will fit here when the air drive is in place. This is how we build the ring guard. We built this form, and we're going to round the leading edge of the ring guard, and then we're going to put the foam in the form and glass the inside until we get a complete ring, then take it out of the form and glass the outside. After completing glassing of the interior of the duct, one then puts a spreader assembly inside the duct to hold its shape. And it can be tacked in place with hot melt glue. And there are the grooves for the leading and trailing edge of the ring duct, and also to take the screws for the netting that will go over the front of the ring guard. Now all we have to do is finish up the hard points. And that's all there is to that. One of the most important aspects of setting up your fan is getting the tip clearances to be as accurate as you can possibly get them. You should have a fan of this 20-inch diameter running from 1/8 to 3/16 of an inch tip clearance on the bore. So cut a piece of wood into a block, put a piece of sandpaper on, and through the duct, sand it to shape. And with this removable air drive, you can use the fan to check your fit. Remember, you have one layer of glass to go on the inside of the fan bore. To insert the rudder pivot and the rudder crank pin, we make a tool out of a piece of wood, 2 holes, another block with a single hole, and we insert the bolts that will be the rudder pivot and the crank pin. These are 1/4 by 2.5 inch bolts into the holes. We put the other assembly on the board, and we put the rudder in place and cast the bolt heads in place inside the rudder in cutouts in the foam using the micro balloons. Micro balloons are set. Hopefully we can get the assembly apart. there we have our rudder pivots and our crank pin. You will note that the rudder pivots must be on this line, which is 25% back from the leading edge. The rudder should have 1/4 ahead and 3/4 behind the line. The rudder crank is 1.75 inches back to handle the travel of a Bowden cable. The standard cables have about 3 inches of travel, or plus or minus 1.5 inches of travel, which should give you enough for rudder angle. You'll notice that I've cut out an extra amount on the trailing edge so that if I find the rudder feels too heavy, then I can trim off a little more off the back of the rudder and gain rudder balance. On this small Sev, such as Scout, however, generally that's not a problem. Putting the micro balloons down after putting them on in this fashion, make sure that you don't sand too hard or the foam will sand out rather than the micro balloons and leave a bump. Micro balloons is a tricky proposition. I take a can such as this one, 10.5 ounce, and I put 3 tablespoons of resin in it. 1, 2, 3. Maybe 5 drops of catalyst. And then pre-mix the resin and catalyst. And the same 10.5 ounce can I fill half full of micro balloons. And then I mix it up to a consistency that just won't quite flow and yet won't run. This is very hard to do because you have to hit it precisely, and you may have to try small additions of micro balloons or resin to get the right consistency. You also have to mix pretty aggressively because the micro balloons do not exactly go into the resin. And there I have a mix. Since it's 42 degrees Fahrenheit out here, we're going to catalyze the resin at 2%. We'll also use our heater device that's underneath the table to cure this layup out. It's best to paint the micro balloons with resin before laying the cloth on it, because this tends to smooth the micro balloons out. You'll note that we've raised the panels underneath the heater. This helps considerably in curing out the panels. It is better to put hard points in after the main structure has been established, such as the location of this quick disconnect for the control cable to the rudders. It's very difficult to put the hard points in right where you need them. And so you can put them in after the structure is completed. Then drill out the side. only go part way through. Dig out the foam. Hard point here for rudder adjustment has already been placed, and after the rudder adjustment is complete, we'll drill through this hole through the hard point to finally anchor the position of this part of the rudder mechanism. Pulling hard points appear to be quite a workable solution, and I think we can substitute microballoons for the oak dowel hard points without worrying. There's a couple of hard points. You'll notice I have put tape over the hard points so that I could roll the shroud over and glass the hard points on the other side. Thing that has to be addressed is rotor balance. You should always check your rotor balance, whether you build the rotors yourself or they're manufactured rotors such as these. You'll notice I've taken a pair of the skid material and leveled them up on two sawhorses. To get the level, I use ice cream sticks placed underneath the feet of the sawhorses, and just check the level with an ordinary carpenter's level. Sensitivity of his balance. To do this, you use a couple of pennies, which are 1/10 of an ounce apiece, and you put them roughly 5 inches outboard of the axis of the rotor. And you'll see if it'll sink that particular blade. Now that's 2/10 of an ounce at 5 inches. That's 1 ounce of imbalance, and you can see it clearly sinks the blade. Now to balance these rotors, you can add washers under the bolts that hold them together, or you can add bolts through the holes that attach the propeller hub to the hub adapter, or in this case the pulley. These rotors are probably within an inch of balance. Considering how much the single-cylinder engines shake, this is not bad for balance. However, on the large machines, they should be balanced perhaps to 2/10 of an inch because the engines are so smooth running. The tubes are installed by drilling a hole through the shroud, putting a small number 10 machine screw and nut through the side of the tubing, and then potting the end of the tubing in microballoons. We can sand off the extra microballoons and put a layer of glass fiber over it to complete the joint. And let it cure up just like that. They get to use that skid material that we've been using for alignment of the hull for skids. We cut the material off, we round the leading end of the skid and match drill it to the hull. This forward bolt goes through the hull and picks up another piece of aluminum angle to which the stanchion that holds the deck up is attached. You'll notice there are holes in these skids in the flange, and these will be used to hook bungees for transporting the craft to keep the skirt from flapping around in the breeze. And also we will attach some legs to the skids after the skirt is installed to hold the hull 1/8 of its width up off the ground for trimming the skirt. Partition skirt is held by this arc of aluminum. This 1/8 by 1/2 inch aluminum is very easily bent into this arc by clamping it to a flat table and then just bending to an arc drawn on the table. And that takes care of the stripping that holds the inner skirt attachment and the skids. Yes, I've been working on the controls for the craft also. Well, here we are at the end of some 2 months of construction, and about 75 man hours have been expended. Rather than watch me drill more holes and sand more fiberglass, we can just look at the hardware and we can see how the controls are installed. The part here is the fan shroud, and it is part of the air drive unit and it fits in bestly. The air drive is held to the hull by means of 4 bolts, 2 fore and 2 aft. The fan shroud assembly goes on with 4 more bolts. It will ultimately have a 2-inch fishnet over the front of it to prevent damage to the rotors, and that will be installed in the final build-up. The next step is to hook up the throttle and the rudder control. All of this hardware is quick disconnect hardware on this craft. It's not necessary if you don't tend to dismantle the craft. And now we have both a throttle and a rudder. We'll cover a few details of these control installations. It was nothing more than a 1/8 by 3/4 inch aluminum strap that can be gotten at any hardware store, and a couple of blocks of plastic are taped to it, and a piece of high density polyethylene is used as a bearing, there should be a large flat area of the aluminum sliding against the high-density polyethylene, so that there's a little control as far as stickiness goes. The control cable is the standard, in this case, quick disconnect ball joint. It can be readily removed. You don't need this in a craft that is not going to be dismantled, or in this case, this craft is going to be experimented on, so I keep this kind of a control cable. The back of this throttle connection where it attaches to the engine, and you can see there's a lever to change the throw of the cable to the throw of the engine throttle, and it's all bent out on a cockeyed angle to keep the control cable from passing over the cockpit area. You should note that all of this hardware has been put together with non-locking hardware, and this has to be changed to nylock type of locking hardware when you finally assemble it. These parts will be taken off and cleaned up, and the craft will be painted, and then it'll be reassembled. It's just a straightforward belt crank that pushes and pulls the control cable. However, in this case, since we have to open up the forward flap in the skirt occasionally, drop the nose for braking, I've made this so if you push on this control, it will pull this cord and pull that flap open, or close the flap by letting it come back, and the bungee holds the steering back. This bar here maintains the position of the control cable. You can watch it function here. This is really not necessary. You could actually take this cord and just run it forward to a handle here and pull it open, just as I've done in the Vanguard. And this mount for the control cable could be fixed to this surface, so this complexity would not be involved, but I like to experiment with the control system in operation. Notice the way the rudders turn relative to the way the wheel turns. Now of the rudder control mechanism, you notice right here is a stop block to prevent the rudder from going too far. You notice there's a stop both ways. It hits here, right there, and it hits here. This can prevent the rudder from swapping directions on you and actually turning inside out and throwing the machine out of control. This is the slave bar that drives both rudders. Just simple high-density polyethylene blocks. Some of this structure will be cleaned up, some of it will be replaced. You'll notice I've drilled several holes as for test positions, and obviously these have to be replaced with nylon. We might have another look at those stops. It's very important to have those stops in place. You can see how they work. It hits there, and it hits there. And that's all there is to it. This keeps the rudders from swapping around the wrong way and jamming the control mechanism. The switch has also been installed. When the switch is down, the switch is closed and the magneto is shorted out. When the switch is up, the switch is open and the magneto is ready to run. The switch should be positioned so that it can be easily flipped off in an emergency to short the magneto and drop the vehicle into the water, but it should not be positioned so that this could happen as an accident, because sometimes it's best to keep the machine running when you're trying to get out of a problem. Note that the Bowden cables are secured by plastic ties, just like that, and the moldings that hold the skirt to the edge of the craft are also complete at this time, and it is completely fair to sand off the edges of the hull to get the shape correct for the skirt fit, And these aluminum strips can also be used to verify that the individual lengths of the skirt panels that you're building are correct. It's time to make the skirt. The first thing you start with is a line at right angles to the edge of the skirt material. And then you lay out the, as in drawing 3 on the scout plans, you lay out the line that corresponds to the upper attachment line. And then the outboard line. Look at the left side, upper left side on drawing 3 in the scout plans. See these dimensions. This is the outboard line. And the ground contact line. And the inner attachment line. The joint on the end of the skirt extends past this line, the outboard line. It has to be extended to the other side of the line you initially drew, and now we can get ready to strike the arc. The arc, we look again at the upper left-hand corner of drawing 3 on the scout plan set, and we notice that the arc hangs 3 1/2 inches beyond our initial line. And we mark that off. Then we can take a stick with 2 holes in it that are 16 1/2 inches apart in the case of the scout. Place it on our marks and strike the arc. I have the first line we drew, the arc, and these lines crossing it. We now draw the lines corresponding to the actual end of the skirt panel just by finding the tangency to the arc and drawing them. And remember that this inner one, if you look on the upper left-hand corner of drawing 3, you go in 7.3 inches on the opposite side of the line, and we draw a line to the ground contact line, to the inner attachment line. And then we draw another line that's tangent to the arc. And that completes the layout of the end of the skirt panel. This shape repeats itself through the aft skirt, the aft quarter skirts, and the side skirts. Some people might want to make a template out of plywood or cardboard, and in this case I'm just going to use the skirt material, cut out the end and fold it over, and draw my pattern using the skirt edge itself as a guide. The skirt material cuts very easily with a razor. The aft quarter skirt all cut out. We've kept track of the upper contact line, the ground contact line, and the inner attach line. And we should also keep track of this outboard line, as we will line these up when we glue the individual skirt panels together. You'll notice that there are V-notches cut in the flap, and most of the panels have flaps, and the flaps should be arranged so that the individual skirt panels, when cemented together, will be shingled, in that if a joint does split open, water will tend to flow out of the skirt rather than in the skirt. The curved joints between the aft quarter skirt and the side skirt, here's where these little tabs come into play. You'll notice I placed the inside of the skirt material, the rough side, down. That's the aft quarter skirt, and on top of it I placed the side skirt, the inside material, the rough side up, and that positioning will allow me to fold these tabs over the top and complete the joint, so I can turn the joint right side out and straighten it out. I'm not going to try to do this entire joint in one pass because it's just too long. That much. And now all we do is fold the tabs over, folding them a little bit beyond the V's so that we don't get holes between each individual tab when we turn the skirt around. Should also check to make sure that your outboard contact line and your ground contact line and your upper attachment lines of the two individual skirt panels line up. Now we can do the remainder of the joint. Looks like we're ready to close up the joint. There it is. We immediately turn it right side out. See how it lines up. And this one I'm going to correct. You can open these joints and move it over a little bit. There we go. And there's our joint, all lined up. You notice the upper attachment lines line up, the outboard line lines up, and the ground contact line lines up. So we've got a good fit. These are the skirt drain ports. You notice it's a rectangular hole. This is the aft skirt panel. This is the ground contact line. And these holes must be just aft the ground contact line. It's very easy to get these skirt panels on the wrong way, so you have to be careful here. The flap itself is a double layer of the skirt material to keep it from flapping around as the machine slides over the water, as this will wear the panel out in a hurry. Whenever you have an edge that's exposed, that isn't shingled in the skirt, as the skirt assembly was shingled, you have to fill in the leading edge with cement. And I would do this 2 or 3 times to build up a good solid mass of the cement. If you don't do this, water will ram in the notch between the joints, and water will actually hydraulically separate the flap from the skirt material. If ever you patch the skirt in the field, you should use MEK or acetone to clean it first, And then, since you'll always have this leading edge situation, you should also fill patches in with this filler. However, in the field, you'll not always have enough time to do this, and all you do is apply the patch, and it will undoubtedly be sufficient for the rest of your trip. When you get home, though, you should probably use these procedures, or eventually parts of the patch will work loose. Out the larger arcs, as are shown on the partition skirt, I've taken the molding used to hold the skirt to the edge of the craft and taped it into lengths corresponding to the two arcs in the partition skirt. And I put a nail on the table, and now I can strike these arcs out on the table. Like so. Next step is just merely to roll the skirt material in place. And do the same thing all over again. And that's all there is to it. I'm going to cut the lower edge of the partition skirt a little bit long, as I am not exactly sure where it's going to come out. So I'm cutting just below the edge shown in the plans. And later on, you'll see this material cut off as we tune the skirt. Note the flotation foam applied to the inside of the tubular parts of the skirt. This foam is applied, in this case of the Scout, 3 inches outboard and 3 inches inboard of the ground contact line, which has been redrawn on the inside of the skirt. The foam is ordinary backpackers sleeping pad foam that you can get at any mountain shop or just about anywhere backpacking equipment is sold. And you must coat the bonding surface with the cement first, let the cement to cure out for perhaps 10 minutes, and then recoat the foam and coat the skirt material and close up the joint. Now these joints can be opened up after curing for about a day. They get pretty strong, and to make it easier to open them up in case you have to reposition them, an ordinary hair dryer applied to the joint, especially as you peel it open, applied to the point where the peel stresses are highest, will allow you to open the joint with a minimum of force, and you can reclose the joint merely by recoating with the cement, allowing the cement time for some of the solvent to evaporate, and the joint will be just as strong as it was before you opened it up. The skirt is now finished. We have the principal part of the skirt. We have left and right halves to the partition skirt. And we have the bow skirt. And the remaining joints will be assembled when we install the skirt on the sail. Now we have about 83 hours of work into this project, and what remains is primarily finishing, painting, and also putting the Dacron aircraft fabric deck on, which is really part of the main finish. So we'll have to get to work and disassemble it and clean everything up. On many of these surfaces, you get a coating of Bondo light, or in this case it's called micro light out of naphtha. This is a lightweight filler that fills up the glass pattern. Now, this won't make the machine fly any better, but it will make it prettier. So a lot of people won't even do this at all, and some people will make the whole Sev shine like a mirror. It's your choice, but this is how it's done. The first thing, you take the rough glassing and you knock off the high point. Step is to apply the filler. So I usually tease a little bit out onto a piece of scrap wood. About that much. This is the catalyst. This is polyester resin with micro balloons in it, which I prefer to buy rather than make from the micro balloons. Then I squeeze the catalyst out into it. Notice the catalyst is in a paste form and it has a small amount of dye in it. So when you mix it, you can make sure that the catalyst is distributed through the mix. It's normally done at about 70 degrees Fahrenheit, but it's 40 out here, so we won't have to race to get the filler in place. Mix it for about a minute until the dye is evenly distributed. Put it down and start spreading. Try to spread it thinly, and remember that to not be too messy, because whatever you make a mess, you're going to have to sand it off. Now, one thing that you should be cautious of is that quart can has about 2 pounds of material in it. After you're through sanding it, you'll have left a pound on the Sev. So there's a downside to a nice finish, and that's a little added weight. So be careful when you add things like this. The trick to sanding this is do not press down hard on the sandpaper, or the sandpaper will fill up. There's a lot of sanding to be done. I'm using about a 60 grit sandpaper. It's a matter of preference, and a rubber block for backing. You should always try to sand with a rubber block and not try to chase pits, but later on fill the pits in with more of the Bondo to get a smooth surface that's not wavy. Aircraft fabricon is a relatively simple matter. The first step is to paint all the interior surfaces of the hull, but do not paint those surfaces that the aircraft fabric is going to be glued to, because the glue tends to be incompatible with just about any finish. All of the hardware is installed before putting the aircraft fabric on, just as a matter of convenience. The aircraft fabric is put on by bonding only the smallest of elements, because the solvent in the aircraft glue seems to evaporate extremely rapidly. Just put the glue down and press it in place. There's no need to attempt to get the aircraft fabric tight. close the glue joints by rubbing on the outer surface. Joints may seem very unsatisfactory when you first perform this operation, which is odd considering this stuff is used on airplanes, but the joints seem to work. This covering material is Seconite 101, which is the heavyweight aircraft fabric. Now it sort of looks like an unmade bed. All you have to do to fix that is an ordinary iron set on linen or its higher values, and go to work on it just by stroking it like this. It will straighten out. You have to be careful because you can actually over temperature the fabric and bend the frame. You can also burn it if you stop on it. That's all there is to it with this Seconite 101 and the butyrate dope cement now drum tight and ready to paint. It's normal to apply dope or lacquer to this type of surface, but we're going to try enamel paint, and instead of using a spray gun, we're going to use one of these, a roller. Just roll it on. This would not be a bad place to start playing with your intended decorations. This coat is primarily to provide an opaque coating to keep the sun from getting to the fabric. I've got a 10% thinning of a standard brand of enamel in this case. And it's all painted. The roller makes quick work of this. Sometimes it's just too cold to work outside. In this case, it was bright and sunny outside, yet condensing water was raining down on our project and freezing solid on the surfaces that I was trying to paint. So it's time to give up and haul it inside. Fortunately, both Scout and Vanguard can be carried through a normal sized door. For larger projects, you'll have to have that polyethylene tent held up with PVC tubing and the heater to keep things warm. And now it's time to install the skirt. This is normal contact cement, the variety that you put countertop material down with. First step is just to paint the joint that we're going to fasten the skirt to. There's no intention of making this joint small. It's primarily to hold the skirt in place while we take up the metal, and also to keep water and debris from bubbling through when the vehicle's operating. This contact cement has to be applied to both surfaces, similar to the skirt gluing cement. Line up those center lines and start applying the skirt. Securing the back next, and put these side skirts on. And I would glue them on all the way to the front before attempting to put the molding on. You should start putting your moldings on at the front so that things can come out and the moldings can match up. This is the control door, and this is the way you collapse your front cushion, by pulling on the cord in the craft and opening this door. And remember that you have these two triangular vent holes also to put in the skirt. Has now gone from the late flowers of October to the January freeze down. We've spent precisely 3 months on this project now. There are 105 man hours involved. The net is put on using small plastic P-clips. You start to put the net on by installing the top centermost fastener, and then you stretch the net 45 degrees downwards and pick up the second point down here and do the same on the opposite side. Then you keep adding P-clips inside and outside with your starting point, and at some point or other you're just going to have to do the best you can, because it is a round ring guard and a net with square holes in it. Installing the inner attachment of the skirt, you can start with this notch that we have in the forward quarter skirt on the inside flap. Remember, this is the side skirt, this is the forward quarter skirt, and line it up with the junction between the plow plane and the bottom panel of the craft, and that's where the skirt is located. Just mark the points with a marker. And then you can punch small holes in where the mark is. Place your metal over it. Get a screw, a little dab of silicone caulking, and start your screw. Remember, the important thing is that this little V-notch line up with the junction between the plow plane and the bottom of the craft. And then you can work either forward or aft to complete the joint. What we do here is finish the metal parts. The primary problem with these metal parts is they rust, especially in saltwater use. The first part of the treatment is to degrease the tubes. Here we used ordinary laundry detergent, and we pulled a cloth swab through the tubes to make sure that inside and outside they're degreased. Then we used a solution called metal prep, which is a mild acid solution, to etch the surface. We dried them, and what we have here is zinc chromate primer, which is bought in an automobile store. This is a dip tank so that we can get both the interior and exterior of these tubes for protection on the inside. Protection on the inside is very important, especially in saltwater use. Finishes are normally sprayed, but that is really only for cosmetic reasons. I prefer preservation over cosmetics, and the zinc chromate primer is absolutely essential for saltwater use. This tape is for more than cosmetic purposes. It can seal in areas of the hull that might be penetrated by water, such as the aluminum rail that holds the skirt to the hull, and also where the deck fabric meets the wood on the inside coaming of the deck itself. I would buy a good brand of this tape because cheap brands tend to lose their color and lose their adhesive in about one season. The tape adheres quite well to this oil-based enamel that I used to finish the craft. It's used on the outside of automobiles, so it ought to last fine here if it's of good quality. That I've installed a gasket on the hull to seal the air drive to the hull to keep air leakage to a minimum. The gasket is made from a backpacker sleeping pad and bonded to the hull using ordinary kitchen countertop contact cement. The first step in tuning the skirt is to block the machine up to its expected hover height, which in the case of all the Sevtec machines is 1/8 the hard hull width of the machine, so that we can trim the bow and partition skirts. These are just simple blocks bolted to the skids, and the craft will rest on these blocks as we determine the height of the machine, so we can trim the bow skirt and partition skirt precisely. This is one of the more important operations to get a good running machine. What we're going to do here is trim the bow skirt and the partition skirt. It should be emphasized that this should be done before you try to operate the machine. The Sev is now sitting up on its blocks that we attach to the skids. That's why it's so high. And now we have to go in and draw lines at the base of the bow and partition skirt so we can define our cutoff. You'll notice that the machine is tethered. This machine's not any real danger, but larger machines will skate around on you. You'll see that I'll put some buckets of water in the Sev to give it a little weight to shake the skirt. And I'll also shove a stick under the edge of the skirt to keep it from bouncing. On flat surfaces like this, the skirt tends to set up a buzz or a bounce, and if this happens to you, you have to shove things under the edge of the skirt. So I guess we'll go ahead and I'll start it off. You'll note that the propeller is removed for this run. We've already checked the power switch, and we know that we have a good shutoff. This engine has a choke-o-matic, so we put it in choke with the throttle lever. in this flap to get through the bow skirt. It absolutely has to be done in larger machines. And to note the trim, I pushed the skirt down, the air cushion vehicle down onto its blocks, so I got the right hover height. And the marks probably don't show up too well, but all I did was put the pin flat to the ground and very tenderly drew an edge like that. And it puts a mark about 1/4 of an inch above the actual contact line. And this is where we'll make our trim, is 1/4 of an inch below the marks. You'll notice that I'm not only cutting that extra we left on the partition skirt when we made it, I'm cutting a little more than that. Your mark will wobble around a little bit. You just straighten it out with the scissors and you'll be safe. And there's your trim. Critical joints, as these bow skirt joints, can be pop riveted, just like Levi's are pop riveted, to increase the strength. I would keep the pop rivet away from the actual running surface so the pop rivet will wear out rapidly. These are 1/8 inch aluminum rivets, and I have a little spacer plate, washer type affair, that increases their effective area. And it's good insurance on these critical joints, although I generally have not had any experience with catastrophic failures. Time to remove the feet. You can take a lot of these marks off the skirt if you wish with acetone. flew right out of the shop. I don't recommend that such complicated terrain be taken on by most builders of these SEVs, however. This also demonstrates that this high-tech construction can be performed under very primitive conditions. It does not require elaborate facilities to build a high-tech Sevtec SEV. I spent 128 man-hours on this project from October 4th to January 14th, and it is finally done. I hope it's appreciated that this was an actual construction of a SEV, not a series of demonstrations. And our shop, despite having 2 snowstorms, 3 windstorms, several rainstorms, and a couple of freeze-downs, served quite well for this high-tech construction. This is an ideal project for a school group and is far more relevant than the typical wooden bookshelf of yore, and is bound to keep the kids quite interested. It should be noted that the materials used are quite safe. Polyester resin is a very safe material. The MEK catalyst has to be given some care, and there are safety precautions on paint cans and such that should be adhered to. Quite frankly, your most dangerous chemical that you're going to be involved with is H2O, so be careful when you operate the machine, and go out and have fun. And all I can say is we are finally